This is a different panel from the one I chaired this morning, looking at the science of ageing and where that is taking us. In recent years, there has been, ageing is something we've worked on for decades, the science community has, but in recent years, a real explosion in not just ageing science, but the number of scientists working on ageing, the number of new institutes opening up to do it, but also new biotechnology companies trying to develop drugs to treat ageing. And I want to explore what's going on in ageing science, why that's happening, and where it could be taking us. I think that's possibly the most interesting of all these questions at the moment. And we've got a fantastic couple of guests here to help us explore that. Professor Lynne Cox is sitting right next to me here, a biogerontologist at the University of Oxford. And Lynne is principal investigator of the Lab of Aging and Cell Senescence at the Department of Biochemistry at Oxford. We'll come on to what senescence is in a minute, so don't worry if you don't know what that is. And also Stephen Cave, who's director of the Leverhulme Centre for the Future of Intelligence and a senior research associate in the Faculty of Philosophy at the University of Cambridge. Thank you very much for joining us. Stephen's research, in the context of this at least, focuses on the ethics of life extension, and he's also authored two excellent book, well, one excellent book on ageing and another one that's yet to just about to come out as well. So we'll follow that. But let's just dive in. What is the difference between getting older and aging? Because I think at the heart of this, we're saying, and Steve Horvath there was saying, there is a difference. We don't all age in the same way. Is that what's really at the heart of all this?
Yeah. So my view is that there are two types of aging. There's chronological aging, which is how many birthdays you've had, and biological aging, which is how fast things start to go wrong with the passage of time. And biological aging is different for every single one of us, and it depends on what we call the exposome, so your lifetime exposures, right from when you were in utero, all through your life. So where you live, what you eat, how much exercise you have, how much stress, and that can be stresses from communities. So people who live in areas of violent crime have more stress. People who are exposed to high-fat diets in childhood age faster. There are all these sorts of things that make us age faster. Things that we can actually modify, but also things we can't. So everyone's got different genes. They inherit a mix of their genes from their mothers and their fathers, and that actually changes how we age. And then you heard Steve Horvath talking there. And Steve works on little switches on the genes that determine what gets switched on and what gets switched off. And those switches can be changed by our environment, by everything that we're exposed to. So aging is different for everybody. No one should ever be blamed for getting sick when they get old, because it's not your fault, even though there's all these so-called lifestyle factors. But it is a combination of everything that you have lived through in your lives that affects your biological age, as opposed to how many birthday cards you've had, how many times you've been around the sun.
I'll come on to talk about what some of the drivers of that are.
Yeah.
But Stephen, I was thinking, we do all experience aging in very different ways. I think we're all very aware of that. We talk about a good old age. Some people we know live till 106 years old, smoking 20 cigarettes a day, and others live very, very healthy lives, but die very young from chronic illnesses. Our perception of aging as humans, is that embedded and important in this discussion?
Well, our perception of aging has changed very little over the last few thousand years. I mean, if you go back to the Bible, then you hear of people living 70 years and 10, or you know, if they're particularly strong, 80 years, so 70 or 80. In Hindu traditions, you see the same. You know, in Shakespeare, he talks about the 7 stages of life. So our basic conception of what a life looks like has changed very little, even though life extension has really doubled almost in the last 150 years or so. But that, of course, was largely through solving the problems around infant mortality. So the vision of what a good human life looks like has changed very little. But now, and only in the last few decades, have we started to ensure that older people can also live much more healthily. You know, if you look back to accounts of older people in Shakespeare, for example, they're described as senile, as losing their senses, as losing their powers. But now it's possible through the ways in which we understand a healthy lifestyle, and also medical interventions, of course, for older people to live much better than they ever have before.
So, is there a biological limit to how old we can get? And if so, what is it that's underlying that? And therefore, what are the targets that ageing scientists are interested in looking at?
Okay. So you mentioned the people who live to 106 and are smoking and drinking and doing all the wrong things.
A colleague, by the way,
that is
endorsed
not lifestyle advice.
The Sky News.
So a colleague near Barzilai in America has identified a group of people who live, they're super centenarians, they live well over 100, sometimes 110, 115 in good health. They still die. They go to bed, they don't wake up. So we know that healthy long life is possible, but we know that nobody has ever made it past 122 and a half, and that was Jeanne Calment, a French lady who quite remarkably is the longest documented lived human. But we think that there is a limit, and with these super centenarians, what seemed to happen is their bodies just simply ran out of steam. So our bodies keep replenishing themselves, they keep restoring themselves through things called stem cells that divide and make new cells. And these supercentenarians simply ran out of stem cells. So of course there's this thought that if you replace the stem cells, you might carry on going for a little bit longer. I'm not sure whether that really is the case. We accumulate a lot of damage over our lifetimes as well, and simply putting in a few cells that might repair things might not be enough. I'm not also sure that that's what we should be doing, and that's another point that we ought to be coming on to.
We'll come on to, but help me understand. So we clap out as we get older, but what are some of the, but as I understand it, there are several sort of pillars that scientists look at that are driving this aging process. Is there a sense that they can be firstly identified, and then if we found them, can we actually interfere with them to prolong healthy life?
Yeah, absolutely. So in 2013, a group of scientists got together to identify things that are shared across all aging, common things that make us age, and they're called the hallmarks of aging. And they all happen at the cellular and molecular levels, but you don't have to be a molecular biologist to understand them. So things like, as we live our lives, we get exposed to things like ultraviolet light, or you go for a medical x-ray, that damages your DNA. So accumulation of DNA damage over your lifetime makes you get older.
So it's true, too much sun gives us wrinkles.
Too much sun can, yeah. I mean, you look at people's faces when they're very sun exposed, their skin ages faster. Too many medical x-rays will make you age faster. Unfortunately, children who've had bone marrow transplants and full body irradiation, they age much more quickly. So we know that these sorts of things can drive aging. Things that happen inside ourselves, so we're all breathing oxygen and we need it, and we all eat food. And we burn that food to make energy, but those processes inside our cells can actually make us get old as well. So everything that we do that keeps us alive is also aging us. So oxygen forms a harmful form of oxygen that runs around our cells and damages the molecules there. As we get older, we can't get rid of those. So young people and young people's cells have housekeeping processes. They take out the rubbish on a regular basis. As you get older, your cells get a bit lazier. They can't take out the garbage. So you accumulate a load of junk in your cells as you get old. Older cells don't respond to nutrients in their environment properly. Instead of going, okay, I've got enough calories, I'm going to stop here and I'm just going to sort of be a cell that does what it needs to do. They can't signal properly. They can't understand the signal of the nutrients coming in to give the right response at the other side. So they just carry on growing and growing and growing, but they can't divide. And if they can't divide, they can't repair your tissues. So we know all sorts of things like this, like the stem cells just running out of steam. So these are all the hallmarks of aging, and they all seem to integrate, pull together to drive cells into a process called senescence. And cell senescence is simply normal body cells that have accumulated a whole pile of stresses and changes over time to a point at which they stop dividing, otherwise they'd be very dangerous. They'd be cancer cells because they've got loads of DNA damage and loads of rubbish accumulated. So they don't divide, but they sit there, and they don't just sit there, they sit there and do harmful things. So they kick out inflammatory mediators. We saw on the video inflammation.
They're sending signals.
They're sending signals to the rest of your body. So we call them zombie cells. So they're undead. They should be dead, but they're not. But they're worse than just sitting around not being dead, because they harm everything else around them. So senescent cells in your body, as they accumulate with age, are making you get older. I mean, I've got some around my eyes because I can tell they're eating away all the tissue structures, and that's why you start getting wrinkles. But they also eat away all the structures around your blood vessels and make them thinner and, well, sometimes more rigid, but the actual structures become less elastic, so your blood pressure changes. All these sorts of things are happening because of your cells going bad. It's really depressing, but...
I was just thinking, I'm feeling it the more you're talking about it now.
But you asked about malleability. We now understand this stuff, so now we can start to do something about it. And I wanted to
pick up on that point. So we understand this stuff. We've been building our knowledge. But what's been happening in the last few years, Stevie? I mean, certainly over my career, I think ageing science is often slightly looked down on. It's a bit of a crackpot field. There were some extraordinary claims made by various people that we could live for 1,000 years. People injecting themselves with strange therapies, some sort of quite poorly founded things. What's the history of the science of ageing, very briefly? But why have things sort of moved on now?
Yes, well, the history of the science of ageing is as old as history. I mean, the first recorded story we have, the Epic of Gilgamesh, is about his pursuit of a cure for ageing and death. And it's a constant throughout history. And you can find in all the great civilizations, in ancient Egypt, some of the best papyruses that have been preserved are, things like a list of medical remedies. This is what you do if you have a cold, this is what you do if you have a broken leg, this is how you stop aging. And of course, some of these remedies were more successful than others. And from the very beginning of Western science, we also see the goal of stopping aging and delaying death or even curing death as absolutely at the forefront. So, Francis Bacon, for example, Francis Bacon is considered one of the fathers of modern science, of the empirical method. Wrote a book about life extension technology, and he was about 65, travelling towards London in a carriage on a cold winter night, when it occurred to him that snow might act, and ice might act as a preservative of living flesh. He got out, bought a chicken from a local farm, shoved it full of snow, and got back into his carriage. He unfortunately caught a cold. He lived long enough to see that the snow did in fact help preserve the chicken, but then he died of pneumonia. Now, this is ironic, but there are interesting things we can learn from this. Yes, it's one of the goals of science and technology. Yes, it's full of wild hopes which aren't, ever fulfilled and probably won't be. But at the same time, there is real progress. He didn't find the cure for aging, but of course, freezing, cryopreservation, really is an essential part of preserving tissues and so on. And through to the 20th century, we saw a lot of different experiments, a lot of interest. Less than 100 years ago, people were taking vasectomies, having vasectomies thinking it would cure aging. They were having bits of monkeys' testicles grafted onto themselves, bits of guinea pig ground up and injected, and so on. And these were serious scientists, some of them Nobel Prize winners, and a lot of very famous people fell for these much hyped breakthrough technologies of their day. But because they then, of course they didn't work, there was a placebo effect, but then they didn't work. And as you say, aging research did fall into disrepute. And in the latter half of the 20th century, a lot of researchers, would call it by other names and be very, very careful about the claims that they were making.
It's suddenly blown up, though, hasn't it? It seems to have come into its own. I mean, so.
And it's about Silicon Valley money to a large extent, and it's about the California dream. I mean, Aldous Huxley, the author of Brave New World, was satirizing the dream of living forever among Californians 100 years ago. So this hasn't come from nowhere. It's part of the Californian dream of, life's beautiful, we can use technology to solve all of our problems, and we can live forever in this paradise. He was satirizing it 100 years ago, but then, of course, what we've seen with the rise of big tech is huge amounts of money, people getting rich, and these are people who are used to getting what they want. They're incredibly powerful, and like powerful people throughout history, they reach middle age and think, oh my God, I've got all this money, what use is it if I'm dead in 20 years? And so they're now throwing their money at serious anti-aging research. And of course, they're buying the time of great scientists who are doing real research, and we really do understand the body much better than we did 100 years ago. So there really is progress now.
So what's the promise then? I mean, there's a dystopian view of this, which is the Silicon Valley, super wealthy, can seal themselves in some sort of oxygen tent, take the stem cells, live for 1,000 years while the rest of the world just carries on shuffling rapidly towards the grave? Or is there a promise of medicines that potentially could really, as Kristen was saying in that report there, improve health span, give most of us healthier lives?
Yeah. Yes. Very simple answers. So there are some very, very expensive technologies being developed, some very expensive therapeutics, fancy antibodies, fancy stem cells costing hundreds of thousands of pounds. But what we also know from studying these key hallmarks of aging is that a lot of them can be modified by drugs that we already have, that have already been used in people. They're known to be relatively safe as drugs can be. And they're dirt cheap because they're off patent. So you don't have to pay Big Pharma an absolute fortune for drugs that will actually do interesting things. So you asked about the change in the field. I would say one of the absolute key things that happened, 2011, a paper came out. Scientists publish in esoteric journals, and it never really makes the Sun or the Daily Mail or whatever, but it's really a key paper came out that showed that if you remove senescent cells from old mice, they live longer, but they live healthier. All of their tissues regenerated, rejuvenated. They were much healthier for much longer. And that, I think, flipped the field on their head. Up till that point, it had been, we can observe things, we can see things go wrong, but we can't really do anything about it. And then suddenly, there's a paper going, you can change it, you can do something about it. And from that point, I think that's where a lot of the Silicon Valley tech got interested, because now it's a technological problem, how do we do this, rather than can we do this? And that has really transformed the field. And the other thing that's transformed it is all the new biology. Everybody here probably knows that we can now sequence our genomes. The first human genome cost £3 billion to sequence. Now you can do it for £100 or so. It's phenomenal what we can do in terms of the tech. And biology is complicated and complex, so they're slightly different things, but complexity means how many different moving parts there are, essentially. And we've got 37 trillion different cells all talking to each other in different ways. That's quite hard to get your head around. But AI and quantum computing and all this sort of stuff is now letting us look at biology in a very different way. We call it big biology. And so we can start to think in terms of what's happening in one of our cells is affecting everything else around the body. And if we tweak one particular process in a cell, what's the outcome going to be? So we know that we can modify this stuff. New technologies, gene editing technologies, new observations, new biology. I think it's come of age now, so we can do something about it.
I want to do some type of questions, but just really briefly, if we can, where are we heading to with this?
Right.
Is it that dystopian view, or should we be wary of that? Or what would be your best preferred option in terms of how we could use this science to better humanity? But Stephen, first of all, give me your thoughts on that.
We have a choice as a society. I mean, the debate for hundreds, thousands of years has been split between optimists who are like, give me the elixir, give it to me now, I want to live forever, and those who say, no, it's not possible, and even if it were possible, it would be terrible, you lead to overpopulation and boredom and meaninglessness and so on. We need to move beyond this sort of utopian versus dystopian vision to ask ourselves, well, okay, if there really is going to be progress, we really are going to be able to live for longer, how do we manage that? How do we make sure that our education systems are robust enough, that our pension systems are robust enough, that we can live in harmony with the planet? If there really are advances in the next 10 or 20 years, which there might well be, we need to take that possibility seriously, then we're going to face immense challenges as a society. And we can make it work out, but only if we take those issues seriously.
Fabulous. Right, let's take some questions from our audience. I'm sure there's a gentleman there. I might take two at a time because that's often a better way to get through a few. And there's a gentleman at the back. So let's take your question first, sir.
Yeah, just a simple question. So I've been watching David Sinclair on YouTube, a lot of this. He talks a lot about aging. And the mice example, he also mentioned the slowing down. Yeah. Has science actually reversed aging?
Great. Has science reversed aging? And you, sir, Jess, I'm pointing. Oh, he's got a microphone already. Wow, this is good. We've got two mics. Go ahead.
I've got a slightly different kind of question, which is actually medical science has kind of prolonged kind of human life, but the thing is, it's kind of if you're a person of age now and you go to hospital, it's almost, well, what is your quality of life, to have certain kind of serious surgeries, etc. So is there like a theoretical limit actually where, say for example, if you were born in the 1900s, you've probably seen so many people that passed away, technology's changed, etc. So like, where is the will to live because you've almost outlived yourself as well? So where does that fit in?
I suppose is that question, yeah.
So can we reverse it? That's a slightly tricky question because we have to be able to measure aging. There is one very, very small trial in America that has looked at a marker of biological age, those little gene switches, the epigenetic switches on things, and suggests that if you're a Silicon Valley middle-aged man who takes growth hormone and a couple of anti-diabetics, it can sort of shift the dial on that biological clock by about 6 months. Now those clocks are reasonably good, but I don't think that that's what we should be aiming for. We should be aiming for the 10 million people who are living with arthritis, the 7.5 million people with heart disease, 3.5 million people living with chronic kidney disease. There's about 1 million people living with dementia. 25 billion pounds a year in the UK spent on dementia. We shouldn't be thinking about fit, healthy people living another 5-10 years. We should be looking at the people who are living in really poor health at the end of their lives and trying to make that better. And I think that might come onto your point as well. So what I'm very interested in is something called multimorbidity. You don't just have heart disease or diabetes or dementia, you generally have all of them. And this really massively impacts on quality of life. And it, not just for the individual, it's massive for the individual, it's massive for their families, but it's also massive for society. So frailty alone, £5.6 billion, and the reason the NHS is on its last legs, unplanned admissions to hospital from sick older people. If we preserve people's health in later life, we preserve their quality of life, their reason for living, that of their families, we have a more productive workforce. And Andy Haldane, from Chief Treasurer of the Bank of England, has estimated that one extra healthy year of life, not extending overall lifespan, but just reducing the period spent in poor health by just 1 year is worth £60 billion a year to the UK economy. When you look at our current deficit, that might do what it might fill the gap a little bit if we could just keep people healthier for longer.
Stephen, any thoughts from you before I move on to the next question?
The question of what we might be living longer for is an interesting one, and if you survey people about how long they want to live, then they're often fairly split on whether they want to live much longer. But of course we don't need to all take the same view. I mean, we don't need to think of life extension as a sentence we impose upon people unwillingly, who would be quite happy to go at 70, but nor do we have to think of it as a death sentence we impose on people who do want to live longer if the technology is available, by depriving them of it. So there are things we do need to come to a consensus about as a society in terms of paying for this and access to this, but then there might be options about what we individually want to do with this technology.
Fantastic. So I saw a couple more hands go. There's a gentleman in the check shirt here and a lady at the back in the black coat against the wall there. I'll take the lady's question first.
Hi. Yeah, so I know you touched briefly on epigenetics. I just wanted to go quickly back to that because I find it quite interesting. So from my understanding, what we do every day can have an impact on sort of, not to get technical, but like the methylation of our DNA. And I've read about how, sorry, okay, there's no it can impact our DNA, and that can in turn impact, say, our children and grandchildren. To what extent do you think, because I've read about obviously lifestyle having an impact on that, what we eat, what we drink, how we exercise, and other sort of factors of lifestyle. What part do you think that has to play in the future of aging and how we could actually impact biological aging of our future generations?
Yeah, great question on the epigenetics of aging, sir.
Yeah, I was going to say, given the financial restrictions of the NHS, is this going to be available to general public, or is it people with deep pockets? And also, how far away are we looking at seeing these benefits?
Right.
Great.
Okay. Can I do that one then, the epigenetics? So my view is it shouldn't cost the NHS more, it should actually cost the NHS less. At the moment, the NHS isn't a health service, it's an illness service. It's very reactive to people getting sick. if we could actually prevent people from getting sick, it's an awful lot cheaper to do preventative medicine than it is to do reactive treat stuff. If you could stop people getting dementia, you're saving 25 billion a year. That's quite a big sum. And a lot of these interventions have to happen sort of very early on in disease. All the dementia medicines that are being tested are in people who have lost half of their brain cells. It's going to be very, very difficult to bring those back. But it should be cheap interventions early on, at the very early starts of disease. It's just like vaccination. It's a lot cheaper to vaccinate against COVID than to have the NHS fall on its knees because the wards are full of COVID patients, right? Prevention is always cheaper. PrEP for HIV, an awful lot cheaper to give pills than to have someone living lifelong with a life-changing, life-limiting condition. Prevention is much cheaper. So if we move towards that model of preventative interventions that can improve health, it will support the NHS, not kill the NHS. It'll also mean that, and these drugs, a lot of the drugs we're looking at, as I said, are off patent, rapamycin, metformin, statins. These things are cheap enough to not be limited to developed nations. They could be used in other countries with less well-developed health systems. So they should be affordable around the world. So I'm not into the make the billionaires live forever. I'm more into improve the health for everybody. I hope that answers your question. And then the epigenetic thing, very, very interesting. So these are the genetic switches. There's a really, to me, worrying study that if you expose male rats to the smell of cherry blossom and give them an electric shock. I didn't do this. They get scared of the smell of cherry blossom. And these are males, and their grandchildren, i.e. 2 generations down the line, are still scared of the smell of cherry blossom, even though they've never had the electric shock. This is programmed not in the genes, but in the epigenome, so those little switches on our genes. We used to think was wiped clear every generation. Now we know they're not. And so the sins of the fathers, right? It goes further back than that. We have to improve lifestyles and remove that socioeconomic inequalities, improve diet for everybody if we are going to improve health for everybody. And it's got to start now because it's going to filter through multiple generations. But we can do stuff about it. So we know that a plant-based healthy diet with lots of exercise can start to shift that biological clock in the right direction. So it's malleable, but also we have to be very aware that people inherit a lot of their epigenome as well as their genome.
Any thoughts on either of those before I move on? I've got time for one more question, so I'm just going to try and squeeze one in. But
yeah, so I mean, on the question of access to this technology, I mean, it's such an important question. All new technologies bring opportunities, but also new challenges, new dilemmas. And if we really do have a suite of technologies that could allow some people to live vastly longer, but was too expensive for everyone to live longer, then that would indeed be a new dilemma. And I think, you know, one lesson from history is that it's very hard to stop rich, powerful people from getting what they want. So we in the UK might decide that we want everyone to have equal access to a bit of this technology rather than a few people to have access to the full powers of it. But we can imagine, you know, some island somewhere, you know, like we have tax havens now, as a kind of life extension haven, and all the billionaires go there to live forever. Which sounds like the, you know, plot of a new reality TV show.
I'll fly to the sky. That's great. I've got time for one more question, but I'm actually going to be really rude and take 2. You, sir, at the back.
So my question was about reversing aging, as you're talking about, but through regeneration. So we've looked into animals that have evolved to be able to regenerate parts of their body, like the zebrafish, who can regenerate their retina and stuff like that. So is it possible in the near future to regenerate bigger parts of our bodies and live longer in that way?
Spare parts for our aging body. And so you had a question too. There's a microphone coming its way to you from behind, in front. No, it's there.
Yeah, we've touched on the lifestyle effect on aging in terms of diet and what you're drinking and your exercise and all the rest of it. But is there a sort of vaguely affordable technology, say a few £100s, that we should perhaps be looking at, the general population should be looking at as potentially going to help us in terms of slowing down our aging?
Yet. Okay, I'm going to give you literally like 40 seconds to answer both of those, sorry.
Okay, sorry. Well, the regeneration question, yes, Altos Labs are looking at switching the epigenome around, which is essentially reprogramming. And we know that, that there are some companies out there, not just Silicon Valley, but a lot of companies that are looking at making stem cells that you can put back in so that people can regenerate tissues from within. So say you've got liver failure, maybe get a few liver stem cells in, regrow bits of your liver. I know that people are looking at, after heart attack, using cardiac stem cells as sort of plasters, patches that you put on a heart after a heart attack to regenerate that damaged tissue. So I think it's a really important avenue of research. So great question, thank you.
And this gentleman's one, is there anything on the cusp? Do we have anything yet that's going to make a significant inroad into extending our health span? Or our
one word answer to the question, what affordable technology might help us all to live healthier and longer is exercise.
That's what we've got right now.
So that's your tech that you need.
Brilliant. I'm just going to close by saying, if you could pause aging, what age would you pick? How old would you want to be?
It's almost impossible. I'd want to be fit and healthy, but I'm sort of quite happy where I am now. I'm not sure I'd want to be 19 again and go through all those traumas that you go through at 19. I don't know, I'm fairly comfortable.
There you are. Stephen?
Yeah, people get happier as they get older. I mean, well, right now I'm at exactly the statistically unhappiest age. I feel like a man in my prime, but as people get older, as a rule, they do get happier. Early retirees tend to be very happy. So the idea that youth owns everything, I think is mistaken.
Fantastic. Well, thank you both very much for joining us. It's been absolutely fascinating. And of course, to all of you for coming along and your brilliant questions. Thanks very much indeed.